Hello and a very good evening to one and all. So this is Chris Diana here and I welcome you to the session on calendars. Speaking about calendars hasn't got a very great role to play in the CAT. Okay, but yeah, you may sometimes get a question on LRDI, that is possible. Okay, but if you look at the NMAT paper, okay, then calendar questions do come there. So and that is the main reason of handling this session also before the NMAT exam. Okay. Now, before getting into this topic, okay, we need to know a few things. So, we'll discuss all those first of all, and then we'll go into the concept. First, remember that there are too many different kinds of calendars that are present, the Mayan calendar, the Chinese calendar, the Roman calendar, whatever. But we are presently using the Gregorian calendar. And as per this Gregorian calendar, the most important detail is that the first day 111 was a Monday as per this Gregorian calendar. Okay. Now, the next detail that you have to remember is what is the number of odd days? What is an odd day? Now, let me explain this to you in a much more easier way. Now, what is an odd day? Say for example, I have 8 days. I can say that this 8 days is nothing but exactly 1 week and then one extra day. So whatever is this extra day, that is called as your odd day. Okay, so in simple words, to figure out the number of odd days, what you can also do is you take the total number of days there, divide it by 7 and check out the remainder. Now if I want to find out the number of odd days in 8 days, so 8 by 7, the remainder is 1. That gives me the number of odd days. Correct? Now, next thing that I have to remember is how to figure out the number of odd days for any specific month or years or whatever. So here I'm just going to give you example of a month. Now January has 31 days, correct? So in 31 days, how do you figure out the number of odd days? You take 31, you divide it by 7. 7 goes exactly 4 times 28 and then the remainder is going to be 3. So January month will have 3 odd days, right? Clear. After this, one more major thing. Okay, all of us definitely know that remainders is additive. It's also multiplicative in nature. So we can apply the same thing here, which means that if you want to do 8 plus 7 plus 9, okay, that is 8 plus 7 is 15, 15 plus 9 is going to be 24. So 24 you want to divide it by 7 and I check the remainder. So the remainder obviously is 3. Now you need not add all these numbers. You can do them separately also. 8 by 7 remainder is 1. 7 by 7 remainder is 0 and 9 by 7 remainder is going to be 2. So 1 plus 0 plus 2, that is going to give you the remainder as 3. So this is the additive property of remainders. Now it may not look very useful at this particular moment, but when you get very large numbers, instead of adding them up and then again dividing them by 7, you can easily take small numbers at a time and then divide by 7 and check the remainder then and there itself. Okay, we'll look at its application in the next slide. So this is what you have to remember first of all. Now, before you start doing any kind of a problem, okay, know that the most basic problem that can be asked in calendars is they'll give you a date. Like say for example, today's date they'll take, okay, and they'll tell you to figure out what was the day on that particular date. Okay, so what you have to do is see. If I tell you today is going to be a Thursday. Okay, so what is it going to be after 50 days? What is it going to be after 50 days? What is the day going to be after 50 days? So what you will do, after 7 days, it will again be a Thursday. Next, again after 14 days, it will be a Thursday. After 21 days, again it's going to be a Thursday. After 28 days, it's going to be a Thursday. After 35 days, it's going to be a Thursday. After 42 days, it's going to be a Thursday. After 49 days, it's going to be a Thursday. So one more day is left, so it's going to be definitely Thursday plus 1 of Friday. So what basically was I doing out? I was dividing it by 7 and checking out the remainder. So I told after 50 days. So 50 you take it, okay. So you know that after every multiples of 7 or exactly if a certain number of weeks pass, the day is going to repeat itself. It's going to be Thursday again, okay. So I check it, divide by 7 and now I check the remainder. The remainder is 1. So obviously after 49 days, it's going to be a Thursday again, okay. So because exactly 7 weeks would have passed by. But now there's one extra day, so that's going to be Thursday plus 1 of Friday. So the same concept, okay. If they tell me to figure out what is the day going to be on 2nd Jan 2009. So what I need to do is I have to start calculating my base date. The only base date I know is about 010101, which is a fact, that is a Monday. So right from this day I have to calculate the number of odd days till this particular date. Okay, so if this is a Monday, if the number of odd days is going to be 0, okay, what does it mean? Exactly X number of weeks are passing, which means the day will repeat itself. It's going to be a Monday. But if there's one odd day, then it's going to be a Monday. No, it's going to be Monday plus 1 Tuesday. Right? So if it's going to be 2, okay, then it's going to be nothing but here this is going to be here exactly a Wednesday. Okay, now let us go much more detail also into this. Okay, because I don't want to confuse you here itself. Okay, let's make things quite very evident and then move ahead. Okay, so 010101 was a Monday. So with respect to this date, if you get 0 odd days, then the day is going to repeat itself. If you get 1, then it's going to be nothing but a Monday plus 1 Tuesday, and so on. Okay, but what we are going to do is we are not going to take this as the base date. What we are going to remember here is nothing but the day before this, okay, should have been the last day of the BC calendar. So the last day of the BC calendar would have been a Sunday. Taking Sunday as a base would be much more easier than taking Monday. Okay, so if you start right from the beginning, okay, and start from the last day of the BC calendar, Sunday, if you take this as the base, okay, if you get 0 odd days, then the day is going to repeat itself. It's going to be a Sunday again. If you get 1, then it's going to be a Monday. So it matches very well. 2 means it's going to be a Tuesday. 3 means it's going to be a Wednesday, and so on. So this makes things much more easier. So 6 is going to be a Saturday. So we will be taking this into account. So we will be taking this Sunday as the base date, okay, and not this Monday. We will be taking Sunday as the base date, okay, right. Now let's get into it. And I told you, now, right from the beginning, you have to start calculating the number of odd days. But how is it possible? Till 2009, okay, for 2009 years, you have to sit down and calculate the number of odd days. So this becomes a tedious job in the examination hall. So what we do is we not define, it's like we calculate and keep all the number of odd days per month, per year, per century, and then we keep it so that when we get a question, okay, we do not get stuck with the calculations much. So we'll have predefined values here. Now we are going to get them. So let's go for each month. Okay, now January, February, March, April, May, June, July up to December. Okay, now we saw January has already how many days? 31 days. So in 31 days, 31 divided by 7, the remainder is going to be 3. So Jan is going to have exactly 3 odd days. February, now it depends if it's a normal year or if it's going to be a leap year. I'm just going to talk about a normal year. A normal year, it's going to have 28 odd normal days. Okay, so 20 divided by 7, the remainder is going to be 0, which means February is going to have 0 odd days in a normal year. Then March you have 31. So 31 means it's going to have 3 odd days. So April will have 30 days. 30 days means 30 divided by 7. It goes exactly 4 times. Remainder is going to be 2. So now we know that if it has 31 days, the number of odd days is 3. If it has 30 days, the number of odd days is going to be 2. So here April, which has 30 days, will have 2 odd days. And then comes May with 31 days, so 3 odd days. June 30 days, so 2 odd days. July 31, so 3 odd days. Again August 31, so 3 odd days. September has 30 days, so 2 odd days. October has 31 days, so 3 odd days. November has 30 days, so 2 odd days. And December has 31 days, so 3 odd days. So we have predefined the number of odd days for all the months. Now let's go into years. Okay, for example, if I want to take a normal year, a year can be defined as a normal year or it can be defined as a leap year. A normal year, first of all, I know has 365 days. So you divide it by 7, try to figure out the remainder to get the number of odd days. 7 goes here 5 times. Okay, that's nothing but exactly 35, remainder is 1. So it goes here 2 times and remainder is going to be 1. Which means there are exactly 52 weeks and 1 extra day. So in normal year, there's going to be 1 extra day. Okay, and in a leap year, that's going to have 366, right? So if you divide this, you'll get 52 weeks and 2 odd days. Now instead of doing it this way, I can use my additive property as well. So this data that I've given you is for a normal year. So let's figure out the number of odd days for a normal year. So 3 plus 3, 6. 6 plus 2 is 8. 8 means 1 odd day. 1 plus 3, 4. 4 plus 2 is going to be 6. 6 plus 3 is going to be 9. And 9 means 2 odd days. 2 plus 3 is going to be 5. 5 plus 2 is going to be 7. Now 7 means 0 odd days. So I can say that from the month of January up to the September end, up to September end, or I can say up to October start, okay, there are going to be exactly 0 odd days, which means Jan 1 and October 1, the days are going to repeat itself. So if Jan 1 was going to be a Monday on a normal year, then October 1 also is going to be a Monday on a normal year. Okay, so right, so 3 plus 2, 5, 5 plus 3 is 8. So this gives me exactly 1 odd day. So a normal year, I'm left out with 1 odd day. Now in a leap year, what will happen? This February will have 1 odd day. Correct? So I just have to add this 1 to this, 1 to 1. So that becomes 2 there. So a leap year will have 2 odd days. Got it? Now, next, let's define it. A normal year, we have already derived it. It has 1 odd day. And similarly, a leap year has 2 odd days. Understood? Okay. Now, let me just ask you a small question and you answer it within 30 seconds. If Jan 1, 2002 was going to be a Monday, then what day is it going to be on Jan 1, 2003? Please do answer this. Okay. Now, I know that Jan 1, 2002 is a Monday, and up to Jan 1, 2000 is exactly 1 year passing through, and that 1 year is going to be a normal year. Now, how do I figure out if it's a normal year or leap year? Check out the month of February. February of the month 2002 is passing. Correct. And 2002 is a normal year. So, February month affects the number of days. Correct. It defines whether it's a leap year or a normal year. So the February month here is of the year 2002, and that's going to be a normal year. So normal year is passing, so there's going to be only 1 odd day. So the day is going to be Monday plus 1 Tuesday. Similarly, one more small question for you. Please do this. If January 1, 2004 was a Monday, then what day is going to be on January 1, 2005? You tell me now. Yes, obviously, this 1 year that's passing, the month of February, that's going to be past years of the year 2004, which is a leap year. So, this 1 year that's passing is going to be a leap year, which will have 2 odd days. So, the day will be Monday plus 2, which is going to be a Wednesday here. From here, one more thing that I can define is, see, Jan 1, 2003 is a Tuesday. So, the day before this, which is nothing but December 31, 2002. What day is it going to be? The day before this, it has to be a Monday. Correct. So if you look at a normal year, the first day of the year and the last day of the year will be the same. Okay. Now let's come to a leap year. In the leap year, the day before this is nothing but December 31, 2004. So that day has to be the day before this, which is nothing but Tuesday. So in a leap year, okay, the first day and the last day will be the consecutive days. If this was a Monday, this will be a Tuesday. If this was a Tuesday, this will be a Wednesday. So if this was a Wednesday, this would have been a Thursday, and then so on. So they will be consecutive days. So this thing is something which you have to remember. Okay. So in a normal year, the first day and the last day of the year is going to be the same. For a leap year, the first day and the last day will be the consecutive days. Right? Done. Now, after this, let's derive the number of odd days for the first 100 years. In the first 100 years, I know the data only about a normal year and about a leap year. Correct? So now, let me divide this 100 years into normal years and leap years. So before this, you should know as to what is a leap year. Please define what is a leap year. Please define what is a leap year on the chat box. So most of you here will be telling me that a year which has 366 days is going to be a leap year. So if I randomly give you a year, how do you figure out whether that year is going to be a leap year or not? How do you figure out whether that particular year that I'm going to give you is a normal year or a leap year? Please put that on the chat box. So most of us actually what we feel, most of us feel that every fourth year is going to be a leap year. Every fourth year is a leap year. No. Okay, every fourth year is not a leap year. Okay, every fourth year is not a leap year. You have to understand that 1 year is not going to be 365 1 by 4. It's a little bit less than this. So what happens is the fourth year, I am adding it as all this 1 by 4 and putting it as 366. Correct? But there's a slight deficit that's created. So to overcome this deficit, the first century is not a leap year. Second century is not a leap year. Third century is not a leap year. But the fourth century is a leap year. So if it's a normal year, every fourth year is a leap year. But if it's a century, only every fourth century is going to be a leap year. Like say for example, 4 is a leap year, 8 is a leap year, 12 is a leap year, 16 is a leap year and so on. But 100 is not a leap year, 200 is not a leap year, 300 is not a leap year, but 400 is a leap year, 800 is a leap year, okay, 1600 is a leap year and so on. Understood? Now, so in 1 to 100 years, first of all, I know that 100 years are there. If you divide it by 4, you will get 25. But 100 is not a leap year. So there will only be 24 leap years. And obviously the remaining have to be normal years. That is going to be 76 normal years. Correct. Now every leap year, okay, has 2 odd days. So 24 leap years will have 24 into 2 odd days. And every normal year has 1 odd day. So 76 into 1. Now going to the next one. This one. This is going to be 48. Now 40 divided by 7. I can use my additive property, right? So 40 divided by 7, the remainder is going to be 6. And 76 divided by 7 also, the remainder is going to be 6. 6 plus 6 is going to be 12. 12 by 7, the remainder is going to be 5. So there are going to be 5 odd days. Now we'll go for the next 100 years. The next 100 years also, remember that again there are 100 years and 200 is not a leap year. So you will have 24 leap years and 76 normal years only. So if the base equation is the same, the answer also has to be the same. So here also there's going to be exactly 5 odd days. For 201 to 300 years also, 300 is not a leap year. So you should have the same calculation. So again a 5 odd day there. Okay. And then finally 301 to 400 years. Now remember that 400 is a leap year. That means you'll get 1 extra day here. So 5 plus 1, 6 odd days will be there. Okay, but what you actually got to remember from the whole of this, is this particular table that I'm going to give you right now. Okay, don't mug this up, my dear. Okay, I'm just going to give you a table which you need to remember. Now, the first 100 years, there are 5 odd days. Okay, the first 200 years, there will be 5 plus 5, 10 odd days. Now 10 divided by 7, the number of odd days is going to be 3. There will be 3 odd days. The first 300 years, 5, 10, 15. 15 means there is going to be 1 odd day. Okay, 15 by 7, remainder is 1. And the first 400 years, so 5, 10, 15, 15 plus 6 is going to be 21. 21 is a multiple of 7, so that's going to have 0 odd days. So the first 100 years you'll have 5 odd days, the first 200 years you'll have 3 odd days, the first 300 years you'll have 1 odd day, and the first 400 years you'll have 0 odd days. So every multiple of 400 years, every multiple of the first 400 years also you'll have 0 odd days. First 400 years will have 0 odd days, first 800 years will have 0 odd days, first 1600 years will also have 0 odd days, first 2000 years will also have 0 odd days. So that way calculation becomes much more easier. So now let's go into a problem and check it out. See, what day of the week was it on 15th May 2010? So my base date is nothing but Sunday. Correct? So now I'm going to check from that day how many days have completely passed. Okay, after that day is gone, first of the AD calendar comes, correct? So 1st January comes and then so on, it keeps on going. So how many complete years have got over so far? If you take into consideration this particular date, can you tell me how many complete years are over? How many complete years are over? 2009 complete years. I cannot say 2010 years are over because it's still in 15th May of 2010. Correct. So 2009 years are completely over. After that, I still have to now come ahead with 9 years. Okay, 2009 years, right? So 2009, I put it first. Okay, 2009. Then after that, January of the year 2010, February of the year 2010, March of the year 2010, April of the year 2010. And after that, in May, only 15 days. I need to calculate the 15th day because I need to know what day was it on 15th May. So I have to include that 15th May. I have to go up to 15th. So 15 days in the month of May. Okay. Now I know that every 400 years there are going to be 0 odd days. So every multiples of the first 400 years also you will be having 0 odd days. So the first 2000 years you will have 0 odd days. That's why I'm splitting it as 2000. 2009 I'm splitting it as 2000 plus 9 years. So here the first 2000 years will have 0 odd days. Now 9 years I don't have a predefined value. So for 9 years I have to check how many leap years are there and how many normal years are there. So 9 to check how many leap years are there, I divided by 4. There are 2 multiples of 4, so there will be 2 leap years. And obviously the remaining out of these 9 years, that is 7, are going to be normal years. After that, January. Okay, remember this is a normal year. 2010 is a normal year. So January will have 3 odd days, February will have 0 odd days, March 3, April 2, and in 15 days, divide by 7, the remainder is 1. So you'll have only 1 odd day. Now go ahead, 2 leap years. Each leap year has 2 odd days. So 2 leap years will have 4 odd days. Okay, each normal year has 1 odd day. The 7 normal years will have 7 odd days. Then as it is 3 here, this 3 comes here, this 2 comes here, and then this 1 comes here. I can cancel it for 7 because I know that 7 by 7 the remainder is going to be 0. Again 3 plus 3 is going to be 6, 6 plus 1 is going to be 7. I can cancel the top. I am left out with 4 plus 2. 4 plus 2 is nothing but 6. So there are going to be 6 odd days. From when? From Sunday. From Sunday it's going to be 6. I told you now directly you can write it as Saturday. 6 means you can write it as Saturday. So this was a Saturday. Hope now you're getting this clear. So what I'm going to do is now I'm going to give you a similar problem here and I want you to finish it off within 1.5 minutes. Please do this. Okay, initially you may find it a bit confusing, my dear, but once you start doing at least 4 to 5 problems, then you will start getting into the momentum of it. Okay, so please go ahead with this particular question. So I'm going to give you 1.5 minutes for this. Go ahead. You can follow the steps that we have done previously. Thirty seconds more. Okay, so I'm going to now start the discussion for this. See, what day of the week was it on 20th February 1706? So, how many years have completely passed? Only 1705 years have passed. Correct. Now, I know that every first multiples of 400 years will have 0 odd days. So, I can split it in terms of multiples of 400. So, the closest multiple of 400 will be 1600. Clear? Now, I'm going to split it now. First of all, there are 1600 years. Then 100 more years, which makes it 1700, because I do have a predefined value for the number of odd days for 100 years. That's why I've split it this way. And then remaining 5 more years. Okay, after that comes January of the year 17,006. Okay, and then comes 20 days of February. I need to calculate what is the 20th day of February. So I need to include that day as well. Okay, now in 1600 years, I know there are 0 odd days. Okay, and in the first 100 years, there are going to be 5 odd days, which I have predefined in the previous slide. We have derived it as well. Now 5 years, I don't have any predefined answers. So what I do is I figure out how, first of all, how many leap years are there, how many normal years are there. In 5, divide 5 by 4, there's only one multiple of 4. So there will be 1 leap year, and the remaining 5 minus 1, there will be 4 normal years. And then January as usual has 3 odd days, and then in 20 days divide by 7, there will be 6 odd days. Okay, now further splitting this, every leap year has 2 odd days. So I can write it as 0 here as it is 5 year. 1 leap year will have 2 odd days. 4 normal years, every normal year has 1 odd day only, so that will have 4 odd days, and then 3 and then a 6 following year. Now 4 plus 3 is already going to be a 7, and 5 plus 2 is also going to be a 7. I can cancel it out. So what I'm left out with 6. So again I get a odd day of 6, which means from Sunday is my base date, right? So from Sunday add 6, or directly you can say 6 is always going to denote a Saturday, right? So answer is Saturday for this. So those of you who got this, very good. Now let's move on to the other different types of problems that we come across in the question papers. Okay, the next thing is, previously just remember that you did not have a base date. You did not have a base date. So you considered 111, the starting of the AD calendar, or the previous day, that is going to be the last day of the BC calendar, Sunday as your base date. And then you started calculating. Okay, that was using a fact. But now here a conditional statement is given to you. If 2nd March 2013, so if 2nd March 2013 is going to be a Wednesday. Now note that this may or may not be true. So using the previous method definitely is not going to help you. So what you have to do is, now you have to take this as your base date. They ask you to figure out what was it on 17th October 2013. So what will I do? I will try to figure out the number of odd days from this date till this date. Okay, and which is my base day? Wednesday. So if I get 0 odd days, then Wednesday will repeat itself. If I get 1 odd day, then it's going to be Wednesday plus 1 Thursday. If I get 2 odd days, it's going to be Wednesday plus 2 Friday, and then so on. Got it? So first job always to figure out the number of odd days. So let's go ahead. Now March. Okay, already 2 days are gone. How many days are remaining? From this date, from 2nd March 2013 till 17th October, I have to figure out the number of odd days, correct? So already 2nd March has been counted and they have put it as Wednesday. So after 2nd March is done, okay, March actually has 31 days. So if 2 days are already done, how many more days are left out? 29 days. In 29 days, how many odd days are there? 29 divided by 7, remainder is going to be 1. So 1 odd day. After that comes your April. April has 30 days, so 2 odd days there. After that comes May. May 31 days, so 3 odd days. June 30 days. July 31 days, so 3 odd days. August 31 days, so 3 odd days. Then comes September, which has 30 days, so 2 odd days. But I'm still not done. I need to calculate till October. And in October, I need to calculate for the 17th day. So I need to include the 17th day. In 17 days, 17 divided by 7, the remainder is going to be 3 odd days. Now calculate the total number of odd days. 1 plus 2 is 3, 3 plus 3 is 6, 6 plus 2 is going to be 8, 8 means 1. 1 plus 3, 4, 4 plus 3 is 7, which means 0 odd days. Okay, so 2 plus 3, now I'm going to get a total of 5 odd days here. So if it is 5 odd days, what is the base date? It was Wednesday. So answer is going to be Wednesday plus 5, that's going to be a Monday. Okay, now the same question can be asked in the reverse way as well. They may prescribe to you 17th October 2013 was going to be a Monday. So what day of the week is it going to be on 2nd March 2013? Now do not get confused as to the thing is in reverse order. Don't worry, you do the same way. You will get the number of odd days as 5, right? But this is backward going. So if it is from March to October is a forward case. So you're adding. But from October to March, it's a backward case. So if you know that this is a Monday, to figure out what day of the week was it on 2nd March, that is going in backwards. You just have to subtract the total number of odd days. So go backwards now. So Monday minus 1 is going to be Sunday, then Saturday, then you'll be having a Friday, then you'll be having a Thursday, and then a Wednesday. So Monday minus 5 leads you back to a Wednesday. So you will get it. So going forward or going backward is not going to be a hassle. The same method can be used. So now let's go on to one more different kind of a problem. Okay, and let's see, we have done the concepts behind the number of odd days and how to calculate it, everything. Now, every question calculus is going to be based on the number of odd days only. So now I'm going to give you a question. Okay, try this out. Okay, think about the logic and try this question. I'll give you 2 minutes for this question and then we'll start the discussion. Go ahead with this. Which year will have the same calendar as 2020? And I want you to find out the year after 2020. The year after 2020, not before 2020. Which year after 2020 will have the same calendar as 2020? Go ahead with this particular question. Waiting for the answers. Fast, fast, my dear. Shouldn't be taking too much of your time. Okay, so first thing that you have to remember is they're telling you which year will have the same calendar. So 2 years should have the same calendar means the 1st January of both the years should have been the same. 1st January of the year 2020 and 1st January of that particular year, both the days have to be the same. If the starting is same, only then we can expect the calendar also to be the same, right? So if the day has to be the same, the number of odd days between them has to be how much? Exactly 0. The day should repeat means the number of odd days should be 0. This was the concept. Second thing, 2020, is it a normal year or a leap year? Is it a normal year or a leap year? This is going to be a leap year. Correct. So the next year that you're also searching for should also be a leap year. You shouldn't be searching for a normal year. So let's now just write down a few years, okay, and let's calculate from the year 2020 till which year I'm getting 0 odd days, okay. So that would be the possible answer for me. So first of all, I write down here 2020 up to 2035, I write it down, and the corresponding number of odd days. This is a leap year, no? So 2 odd days, normal year, so normal year, normal, leap, normal, normal, normal. So every normal year will have 1 odd day, leap year will have 2 odd days. That's it. Now let's calculate till where am I getting 0 odd days. So 2 plus 1 3, 3 plus 1 4, 4 plus 1 5, plus 2 is going to be 0. That means 2020 and 2025, they will have the same starting. Okay, till the end of 2020 I calculated, 2025 I calculated, I got 0. That means starting of 2020 and starting of 2025 should have the same day. Now remember that these are 2 odd days, which means it was a leap year, but this is only 1 odd day, that means it's a normal year. So the month of February will come and change the calendar, so this cannot have the same calendar. So go ahead, now check further where are you getting 0 odd days. 1 plus 1 2, 3 4 5 6 7. So by the end of 2030 also I'm getting 0 odd days. So 2020 and 2031, the number of odd days between them has to be 0. The starting of both these years has to be the same, but unfortunately this is a normal year. So calendar cannot repeat. So still proceed. 1, 2, 3, 4, 5, 6, okay. And then 7, 8, which means 1 odd day. 1, 2, 3, 4, 5, 6 and 7. So by the end of 2041 again I get 0 odd days. That means 2020 and 2042 again should have the same starting. But unfortunately again 2042 is going to be a normal year. But this was a leap year, so calendar cannot repeat. So still move ahead. 1, 2, 3, 4, 5, 6, 7. So by the end of 2047, again I am getting 0 odd days. So 2048 starting and 2020 starting should have been the same. And this is going to be a leap year. This is also going to be a leap year. So calendar will obviously repeat itself. So this is how you should have done this particular problem. Okay, good. Now going on to the next type. Again take a total of 2 minutes for this particular question. You take your time and then we'll start the discussion. 2 minutes. Read the question properly. Try this out. Monica goes to the museum only on the first day and the last day in any year. So she goes only on the first and last day in any year. She continues to go in this fashion till the time she finds that she has visited the museum at least once on each of the different days of the week. That means she should have gone on a Monday, a Tuesday, a Wednesday, a Thursday, a Friday, a Saturday, a Sunday. So find the minimum number of days required to achieve this. A minute left. Okay, so let's have a look at this particular question, Madhya. Okay, so let me jot down, see, how do the years come? Let's start with a normal year. So normal, 3 normal years, and obviously there's going to be a leap year, then normal, normal, then again a leap, right? Now they're asking me the minimum number of days. One thing that I should be keeping in mind is, in every normal year, the first day of the year and the last day of the year are going to be the same. So in a normal year, going on the first day and also going on the last day doesn't make sense. So because if you had gone here, you would have gone on a Monday. She would have gone on a Monday itself. So you have to figure out the minimum number of days. They have not said that Monica goes to the museum on the first day and the last day. They have said she goes only on the first day and the last day, which means if at all she goes only on the first day and the last day. Not necessarily goes on both the days. So she can cancel this. She gets up early in the morning. She knows that the starting of a normal year, and she knows that the ending of the normal year is also going to be the same. So will she sleep or she will go? No, she'll sleep, right? She'll not waste so much of time, because if she goes there, then one full year will get added up. So she will be trying to minimize the number of days. So she'll not go on the first day. So she'll start from the last day. So if this last day is Monday, normally I know first day and last day both are going to be the same. So Monday means next day obviously is Tuesday. Okay, so Tuesday, then here Wednesday. Now this is a leap year. Leap year, it has the first and last day have to be consecutive days. So Thursday, Friday, okay, and then Saturday. Now from Monday to Saturday, all the days are gone. Sunday is yet to cover. So next one is going to be a Sunday. Now she knows that normal year starting a Sunday. So at the end also will she go? No, right? She will stop. She has to visit the museum at least once on each, and then she'll stop. So now here from Monday to Sunday she has visited. So she's going to stop here. So how many days did it take first of all? How many years? 1, 2, 3. 3 complete normal years. 1, 2, 3 complete normal years. Okay. And I can take this also a normal year plus 1 year. So 4 normal years. Okay. That's going to give you 4 normal years, or 365. For this 365. For this normal 365. For this, it's going to give you 366. And 1 day in this year and 1 day in this year. So you take the number of days here, you add it up, you will land up with 1463. This had to be the answer. Okay, so I hope now you're understanding. Okay, every question is going to be based on number of odd days only. There's no greater concept. Okay, they can twist the question here and there, but the concept behind anything is going to be number of odd days only. Right. So this question is for you, my dear. So I want you all to take a screenshot of this particular question right now. I'm going to give you around 10 seconds. Please take a screenshot of this question either in your mobile or keep it somewhere handy. Okay. I'll go on to the next slide, because in the next slide only you have the questions. Especially this table is very, very important. This table is quite important. Okay. And remember, I'm reading out the question to you once. Varun wants to create a calendar for 4 years. Okay, for 4 years, and the years are x, x plus 1, x plus 2 and x plus 3. On the different calendar formats C1, C2, C3, C4, C5, C6, C7. Format C1 has all the months starting with a Monday. Now in the year X, January is in the cell C1, which means January 1st was a Monday. Okay, now C2 has all the months starting with Tuesday and so on. Now C7 has all the months starting with Sunday. And okay, right. Now in the year X plus 1, October lies in the cell C3, which means October 1st in the year X plus 1 was a Wednesday. August 1st in the year X plus 2 was a Saturday. April 1st and July 1st in the year X plus 3 was going to be a Thursday. This is how it works. And X plus 1 is divisible by 5 and not divisible by 4 and not by 5. What does this statement mean? X plus 1 is divisible by 4 and not by 5. What does this mean? Yes, it means that it is a leap year. So if X plus 1 becomes a leap year, I can assure that this has to be a normal year, and the next upcoming 3 years are also going to be normal. So below is a calendar with the partial data given. So please just take a screenshot of this, my dear. I'm now going to the next question here. Okay. So here the questions are listed to you, and I'm going to give you a total of 4 minutes. Actually, question number 1 doesn't even require you to solve, because we have done it in one of the previous slides already. Okay, so if you remember, it's direct going to be an answer there. How many entries, which one should be the second entry in the cell C1 comma X? Okay, and apart from that, 2 and 3 should not take you more than 2 minutes. So maximum of 4 minutes for you. Go ahead with this particular question. 4 minutes from now on. So 2 minutes gone, 2 minutes more to go. Put your answers on the chat box. Hurry up. Okay, so time's up for this particular question. Now, let's just go ahead with this. Which month should be the second entry in the cell C1, X? C1, X is here. So they're asking you which should be the other one. Now we saw that this was a normal year, this was a leap year, normal year, normal year, normal year. So in a normal year, okay, another month should come here in this entry, which means I can say that January 1st and that month first should have been Monday, which means January month and that month, okay, you should have 0 odd days between them. And the answer to that is very evident. In the second slide, we saw that if it was a normal year, then the number of odd days between January and October was exactly 0. So January 1st and October 1st had to be the same. Okay, so answer here directly would have put it as October. Okay, but right, so not all of us definitely might have known it immediately, correct? So let us do it. Even if you were a student who couldn't do anything, okay, didn't have any idea about it, but you know the number of odd days between the months, right? You know the number of odd days between the months, correct? So you could have applied that directly. So first, see, let's do it. January, this is a normal year. January has 3 odd days. So 1, 2, 3. So February should have come in C4. Okay, simple. January 1st was a Monday. So February 1st, exactly, see, how many? Jan has 3 odd days. Okay, then Feb has, after, yeah, 3 odd days. So if this is Monday, so Monday plus 3, this would become a Thursday. So instead of doing that, okay, Thursday should come in C4. So simply I'm doing January is here. January has 3 odd days. So 1, 2, 3. February should come here. February in a normal year has 0 odd days. So March also should come here itself. Then March has 3 odd days. So 1, 2, 3. April should come down. Now April has 2 odd days. So 1 and then a 2. So May has to come here. May has 3 odd days. 1, 2, 3. So June comes there. Okay, June has 2 odd days. So July comes along with April. Now July has 3 odd days. So 1, 2, 3. So August comes there. August is 3 odd days. 1, 2, 3. So September comes here. Now September, okay, has 2 odd days. 1, 2. So October comes here. See, we actually did that now. So January and October, the next entry has to be October here. Next, October has how many odd days? It has exactly 3 odd days. So 1, 2, 3. November comes along with February and March. Okay, November has 2 odd days. So now December will come with September. Now December has 3 odd days. But remember that 1, after this the year gets completed. So 1, 2 and 3. So it's going to be here. Okay, now you can keep on completing this one. Okay, but remember that, do we have any question based on the year x plus 1? Yes, we have. How many entries should be made in the cell C3 x plus 1? So I continue the same process. Now January is here. January has 3 odd days. So 1, 2, 3. So Feb will come here. Now this is a leap year. So February will have 1 odd day. So March will come in the next place. Now March has 3 odd days. 1, 2 and 3. So April is going to come here. April has 2 odd days. So May comes here. May has 3 odd days. 1, 2, 3. So June comes down. Okay, now June has 2 odd days. 1, 2. So July comes along with Jan and April. Okay, now July has 3 odd days. 1, 2, 3. So August comes here with February. August is 1, 2, 3. So there, September. September has 2, 1, 2. October is here. So we are on the right track. October has again 3 odd days. 1, 2 and 3. So it comes along with March, November. So November has again 2 odd days. 1, 2. So December comes here along with September. Now again December has 3 odd days. But remember that then it will be of the next year. So 1, 2, 3. So January will come here for the year x plus 2. Okay, now let's finish up that x plus 1 question. how many entries should be made in the cell C3 comma x plus 1? So C3 comma x plus 1, there should be only one entry. That's all. Now, which year have they asked about? If the next year x plus 4 is introduced, so I have to go about x plus 4. So directly jump to x plus 4. Now Jan is here. Now Jan, 1st Jan, okay, 1st Jan of this year x plus 2, a normal year, is going to be nothing but C4, na? So Thursday. So tell me, 1st Jan of the year x plus 3 would become what? One normal year passing, so one odd day. So this is going to be a Friday. So here in Friday, January in that year will come in Friday. Okay. Now after that, I also know that 1st Jan x plus 4. Again, one normal year is passing, so plus 1, that's going to be a Saturday. So here January will come in C6. So C6 January here. Now they're asking which format will be followed by exactly 3 months. Exactly 3 months. Remember, this is a normal year. And in a normal year, exactly 3 months that follow a particular pattern are November, February and March. So if you figure out in a normal year, February 1 is going to be what day? Okay, that particular pattern will be followed by March and November. So that's going to be the format. Okay, now let's go ahead. So January is here. January has 3 odd days, 1, 2 and 3. So February will come here. So if February comes here, I can say that in a normal year, November and March also have to come there itself. So exactly 3 months follow which particular pattern? They follow C2. So answer is going to be C2 here. So the question, this is actually a LR question, okay, which actually looks difficult. But see, the concept behind this was nothing but again the number of odd days only. Okay, so one more thing, I'm again slightly repeating it. So if anyone hasn't got it, please do understand it. See, January has how many odd days? 3 odd days. So 1, 2, 3. So February 1st will come here. February in a normal year has how many odd days? 0 odd days. So March will also come here. March has 3 odd days. So 1, 2, 3. April comes here. April has 2 odd days. 1, 2. So May comes here. May now has 3 odd days. 1, 2, 3. June comes here. June has 2 odd days. 1, 2. So July comes here. July has 3 odd days. 1, 2, 3. August. August has again 3 odd days. 1, 2, 3. September. September has 2 odd days. 1, 2. October. October has 3 odd days. 1, 2, 3. November. November has 2 odd days. 1, 2. Now December has 3 odd days. But this will take you to the next year. After December, January will be of the next year. So 1, 2 and 3, January comes here. Okay, now from here to here, a leap year, one full year. So Jan 1st here is Tuesday, means Jan 1st here will be Tuesday plus 2 Thursdays. So will come in C4 pattern. Now from here to here, one normal year. So plus 1. So this becomes Friday. Again normal year. So Jan goes here. So this is how we work out on this particular problem. Okay, so with this particular thing, you can fill up the whole table also if you want. So if additional data was asked about the x plus 2 or x plus 3 also, you could have answered it. Okay, so LR problems may be possible as such. Okay, so for that also you will use the odd day concept only. It is very, very easy. So with this, we come to the end of this particular topic, calendars. And by tomorrow, okay, I just request you to finish around 15 to 20 problems on this particular topic, and then definitely you will never ever forget it. Okay, it's just that you have to remember the things that we did in the first slide. Okay, so whatever we have done in the first slide, if you keep that in your mind, okay, all the problems will have a solution to it. That's it. So with this, I would like to end the session. Thank you everyone for attending the session. Good night to all of you.